Let's take a look at a differentiation question from VJC. Part A, find an expression for dy dx in terms of x if y is equals to tangent inverse of square root x squared minus 1. Now let's take a look at the result. If I'm going to differentiate tangent inverse of x, I'll be getting this. So I'll be using this and I'll be doing this question over here. So dy dx will be equals to, referring to this, I'll be writing 1 over 1 plus, instead of x, we'll be writing this square of x squared minus 1, the whole thing raised to power of 2. Alright, so since I have a function in x in here, I'll be differentiating this again. Let me write again. So this square root means I'm going to raise it to a power of half. Let me rewrite this as x squared minus 1 raised to power half. I'm going to differentiate this term here, which is equivalent to this. Let's differentiate it. So I'll be having half times x squared minus 1, reducing the power, I'll be getting a negative 1 over 2. Differentiate inside bracket again, I'll be getting a 2x. Alright, simplifying this expression. Next line. 1 plus, I'm going to handle this square root and this square. So I'll be getting x squared minus 1, multiply. I'm going to change this to denominator. So I'm going to write divide by square root x squared minus 1, and this x, place it here. So the next step, I'm going to write these two together, 1 times x, x. So this one reducing, 1 minus 1 is gone. I left with x squared, and this will be x squared minus 1. Divide this again, I'll be getting 1 over x times square root of x squared minus 1. So this will be answer for part A. Let me erase and we'll take a look at part B. Part B of this question, it is given that y is equals to x raised to the power cos x for x more than 0. By taking logarithm first, find an expression for dy dx in terms of x. Now let's follow the instruction. We're going to take ln both sides. Ln y equals to ln x raised to the power cos x. I'm going to take this one, move to the front, power rule. Next step, we're going to do an implicit differentiation. So differentiating ln y with respect to x, we will be getting 1 over y dy dx. For this one here, we're going to use product rule. Differentiating cos x is negative sine x. Copying this. Add. Differentiating ln x is 1 over x. Copying this. Next will be simplification. I'm going to write dy dx equals to, so I'm going to multiply y here. Alright, I'm just going to rewrite this one in front first. So I'll be getting cos x over x minus of sine x ln x. Alright, now do take note that the question say we need to put in terms of x. So this y, we are going to replace it with this term over here. So next line, we will be getting x power of cos x over x minus sine x ln x. That's all for part B.